the actual mechanism for aging?
Yeah,
Does it
so,
relate it to mTOR?
so the built-in sort of like mechanism was mTOR. mTOR accelerated aging. It accelerated aging in all sorts of different ways. But mTOR, so the idea is that you needed to have a program to accelerate aging. mTOR was the program, and sort of like it turned out that rapamycin blocks mTOR. So it turns out that like by blocking mTOR, you have a marked acceleration of aging. Aging then becomes much slower, and people are not developing the normative changes of aging and not developing age-related diseases.
I was wondering that how many of our body parts are actually influenced by the mTOR?
Say that again.
How many of our body parts or our indicators, our physical health actually are influenced by it?
By mTOR?
Yeah.
mTOR is involved in every cell. So
Every cell.
Yeah, in every cell, mTOR is the command and control of the cell. And you can sort of like look at aging in sort of like all sorts of different the systems. And a real easy the system to look at it is skin. Right? People with skin, like as they get older, universally have deterioration of their skin quality as shown up by having wrinkles. You know, rapamycin stops, like slows down wrinkles. So like you can use topical rapamycin to sort of like slow wrinkles, and they sort of slowed that. Now it's sort of like the skin was very nice to show how it was working when they sort of like used topical rapamycin, and then they did biopsies of the skin. They showed that there was less senescent cells, less chemicals, and sort of like that were being produced by senescent cells, and these less chemicals being produced by senescent cells, they were like, it was resulting in like better quality of skin, a thicker basement membrane, a thicker base of the basement membrane wasn't thinning, so you weren't having sort of deterioration of the skin sort of like quality, you weren't having wrinkles. And so that was showing basically that so they started off, they were just putting topical rapamycin on the skin, but they showed that the effect was decreasing senescent cells and decreasing decreasing the chemicals that senescent cells were making and preventing the structural breakdown of the skin. So
And what about organs?
well, like most of the sort of like organs are sort of like having all sorts of like changes. I mean, the number one sort of like organ deteriorating with age is the brain. Rapamycin is real,
Right.
sort of, rapamycin is real effective with that. For one reason, because it appears to be a real effective in preserving the cerebral microvascular circulation, which is like the prime steroid thing for maintaining. In other words, the brain gets, it's only 2% of the body mass. It gets 25% of the energy. It's an extraordinarily high energy system. And it requires an extraordinary amount of high energy for like maintenance and function. So if you're having deterioration of the cerebral microvascular system, you're going to have, in other words, that results in deterioration. Rapamycin, that's one of the things that is sort of like stopping. It's like helping to preserve the cerebral microcirculation. But it also, the general sort of like thing that it's doing for almost all the organs is it's stopping chronic inflammation. In other words, the idea of like inflammation that's not based on a bacterial infection. It's a non.
Oh, really?
Yeah, in other words, well, like an example is the innate immune system is the thing that brings about chronic inflammation. The innate immune system is basically pattern recognition. It's a system in which, based on the pattern of things, everything looks like a bacteria. In other words, when the molecules like, so an example would be atherosclerosis. Okay, atherosclerosis, I mean, your basic inflammatory disease. So what's going on with atherosclerosis is you start off cholesterol. Cholesterol is like can get oxidized in the tissues. Now the oxidized cholesterol looks different. The oxidized cholesterol to the sort of like cells that make up the innate immune system, they look like, well, these things look different. They're probably bacteria. We should start up an inflammatory process. And they start off a big inflammatory process, and that's sort of like promoting like coronary artery disease. That was sort of like the plaque and the sort of like so forth that's developing. That's the result is this chronic inflammation going on, being triggered by the innate immune system, which underlying this whole thing thinks it's probably dealing with the bacterial infection because the molecules got altered. Right? In other words, rapamycin is stopping the activity of the innate immune system, so it's stopping like coronary artery disease. So like, but this kind of like this kind of inflammatory process of the innate immune system, it drives most of the sort of like age-related diseases. Like that was whether you're talking about like coronary artery disease, or you're talking about deterioration of cerebral microvascular system, or whether you're talking about joint disease like osteoarthritis. It's like chronic inflammation is playing a big role. Rapamycin, like the rapamycin stopping that system, stopping the innate immune system, is sort of like stopping all these like things. But you have all sorts of like systems that are like breaking down and deteriorating as people are getting older, and that's basically being slowed. But one of Blagoslow's ideas that I agree with is the idea that aging and age-related diseases was the same process. In other words, whether you're looking at sort of like things that would just look like age, like normal changes of aging, or things that were looking like age-related diseases, they were very much the same process.